think we're recording now. Hello everyone. Welcome to our Chapter 4 lecture. This is for Social Sciences 225. If you have gotten here in error, stick around, it'll be fun. I am actually working on two different monitors right now, so I'm going to keep looking behind the camera because that's where I have my slides open right now. I am hoping that all of my students are watching this and you have already downloaded the Chapter 4 slides from La Lima. They're up there listed for February 5th through February 10th, Chapter 4, and we're going to be talking today, as I mentioned, understanding the theory behind the standardized normal curve. So I have a note here on the first slide, which I hope you have open now, that while you read through the slides and as you watch this lecture, I want you to remember to take notes on anything that is not 100% absolutely clear for you. We'll do a review on February 10th when I get back on Monday, and you can email me beforehand. You can go onto the forums and ask your fellow students if they have any answers for you, but make note of all of the things that you're not 100% on, because we'll want to talk about these things a little bit more. Also, periodically, I am going to ask you to pause your video and think about what we are learning. Because this is theory, it's one of those things that you can hear it and it makes sense, or you can read it and it makes sense, but if you don't really stop and think, you might miss something that's really important and not quite have it clear in your head in order to be able to repeat it back later. So I'm going to ask that you pause and think about things periodically, or write down some answers or figure out some calculations. If you just play it right through, of course I'll never know, but to entice you to pause periodically when I ask you to, I will also happily make a weird face for you to pause on for funsies. Why not? So we'll practice right now. I will allow you a chance to pause the video and think about the importance of pausing videos. Ready? 3, 2, 1. Yay, welcome back. So we can move on to the next slide, number 2. If you have any questions about your homework, which I'm hoping that you have already completed, please go to the forums or email me. I will have intermittent access to email. I'll be back and I'll have office hours on Thursday, or on Friday, sorry, or I can come in on Thursday if need be. So please, like I said, make note of any questions that you have. Moving on, next slide. This chapter we are going to be focusing once again on the language of statistics and how practicing vocabulary and terms, but we're also really focusing on interpreting the results that we've gotten from these calculations that we've learned how, and understanding what the bell curve means that we were talking about with Chapter 3, and all of the things that we are learning to interpret. We're putting a lot of the theory behind it now. So Chapter 1 through 4 have really been building on each other, and this is kind of the culmination, bringing it all together. Yeah? All right, next slide, number 4. So the normal curve reflects normal distributions. Normal distributions are called this because it's one of these things that just happens a lot. It was noticed that it occurs over and over and over again in population distributions for a lot of different measures and variables. It's just one of these things that happens. It's kind of like how you see a spiral a lot in nature, or maybe you've seen those pictures that compare the veins on a leaf to the central nervous system on a human, to like microscopic brain synapses, to the river system in the Amazon forest. It's kind of like that. You see these shapes over and over again. Well, the normal curve is one of these distributions that we notice happens a lot with human populations for a lot of different things that we measure. And because of that, we developed, of course it wasn't me, but you know, statisticians and theoreticians started putting together this theoretical bell curve that standardizes what we keep seeing over and over. As we've talked about before, most of the population is going to be clustered around the mean. That's going to be the most normal. The largest group of people are going to be right there in the center, and then, you know, a larger group as we get a little bit further out. But everyone kind of falls within this curve. We use this theoretical curve as our basis for interpreting data. Of course, we are not going to have all possible measures of everybody who might possibly take this, so we put our measure and however many cases we have, if it falls within a normal distribution, we can compare it to this curve. On to the next slide. So, do you remember the 1, 2, 3 rule? And yes, I would like for you to think about it. Say it out loud if you want right now. Pause the video. 3, 2, 1. And moving on to slide 6. Let's talk about theory, because this is a theoretical curve. Like I said, it was created with this idea of an infinite number of cases. If we were able to get infinity people to measure whatever it is we're interested in, to take our chapter 3 quiz and see how they did, and if it fell within a normal range, we would see that perfect shape. When we have smaller samples, it's not going to be an exactly smooth. Remember with chapter 3 when we were looking at the differences of telling stories between like a bar chart or a line curve, the more cases you get, the smoother the curve you can be. Well, the standard curve is, of course, infinity cases, so it's perfectly smooth and perfectly well even on both sides, etc. But, you know, since we don't actually have the infinity scores, we just have to work within this theory, knowing that this shape arises over and over and over again. We then align the cases and the scores that we have measured to see how well it fits within this normal distribution, and if it fits well, then that's when we can start extrapolating information and making inferences that if we were able to get infinity people, that basically everyone is going to fall within this normal distribution. Moving on to next slide, number 7, means and standard deviations. So remember in chapter 2 when we were calculating means, mean deviations, and also standard deviations, yeah? We calculated the deviation of each score, x minus mu, or x minus x bar, which is the score minus the mean, yeah? One half of these deviations would be positive, the other half would be negative, because one half is higher than the mean, one half is lower than the mean. And then we squared all of these deviations, summed the squares, divided by n, or n minus 1 for samples, and we took the square root, yeah? And that is how we got the standard deviation. We learned how to do this, but we didn't really get into what exactly does this mean. Moving on to next slide, number 8. So we were calculating the standard deviation of the standardized normal curve. This is where it comes from, yeah? So the standard deviation in a graph is the distance, the standardized distance above the mean and below the mean. And it's standardized so that 0 is the mean, and then one standard deviation above and below is going to include 68% of the population, 2 standard deviations, about 95% of the population, and 3, 99%-ish, yeah, with the 1, 2, 3 rule. But this is standardized because it's based on that theoretical curve, based on what we see of how populations kind of fall. Moving into slide number 9. Here we have the Wechsler Intelligence Score curve again, as we've looked at a few times. If you look at the scores on the baseline of this standardized curve, we mentioned this during our chapter 3 lecture. By the score, by the numbers that you see on the baseline, you'll see that each deviation here is 115. Now the mean is set at 100 for this, but if you're talking means to standard deviations, it's mean is 0, 1 standard deviation, 2 standard deviation, 3 standard deviation. But within this particular measure, they decided to set the mean is 100. This is the scores, yeah, so the score of the mean is 100. 1 standard deviation is 15 points, so 15 points for 1 standard deviation up, another 15 for 2, another deviation for 3. So that's where the standardized scores for the deviation go, yeah? But when we're thinking about like the actual, if we're just looking at deviations, the mean is 0, 1 standard deviation, 2 standard deviations, and on. That's always level. Regardless of what the actual score is, that's always how we're going to see the inference, yeah? So what we're seeing here is the percentage of people who make the score reduces as you move further and further away from the mean. At the mean you have the most people, yeah, that's the mean, median, and the mode. And then when you get to one standard deviation, it's going to be fewer at that exact score. Two standard deviations, even fewer at that exact score. And then also if you're looking at above the score, so between the mean to one standard deviation is about 34% of the population. Between one standard deviation and 2, it's going to be fewer, and 2 standard deviation to 3, it's going to be even fewer. So that's where we see this shape. So going on to number 10, slide number 10, recapping. Normal distributions are common enough in reality that we've created this theoretical curve and these like statistical analyses in order to extrapolate information and inferences that are useful about the measures that we can take. Yeah? When we make these calculations for any variable, anything that varies, anything that we can measure, that we know falls within a normal distribution, we can align it within this curve by setting the mean to 0 and setting the standard deviation at 1. We can then infer and are able to make inferences about a much larger population than whatever our sample is, if our sample seems to be falling within a bell curve, that up to infinity scores, if you have plus or minus 1 standard deviation, in between that's going to be about 68% of the population. In between 2 standard deviations out on either end, it's going to be about 95% of the population. So this here is getting to be inferences. Yeah, this falls within the theory of understanding how this curve works and why we can take our sample and then make further inferences about a population far beyond our sample. Okay, so pause here for a minute if you need to think about the theory that we've talked about so far. Look back over your book if you need to or into your homework. 3, 2, 1. Alright, moving on to slide number 11. This brings us to the table of areas under the normal curve. So this is available in your appendix on page 318 and 319. Okay, I'm going to need you guys to memorize this by next Monday, okay? I'm just kidding, I would never do that to you. That's what tables are for, so you don't have to memorize these numbers, right? You can look it up. What I need for you to do is be able to understand the table. Be able to understand how to read it. If you get a Z-score, what can you learn from the table? I need you to be able to look up this information and reliably make calculations based on the score and the proportions that are available from the table. Yeah. So, also hopefully you have practiced already in your book. You've done your homework. You've read through the chapter. Let's talk about this anyway. So you remember Z-scores. We first started this in chapter 2. Had a horrible, horrible definition that didn't really tell us all that much, and we learned how to do the calculation, but didn't really go into what does it mean or what is it for. So here's what it's for, yeah? So the Z-score tells you how far you are away from the mean along that baseline in the normal curve, yeah? So Z-scores do line up with the standard deviations, but it's not exactly the standard deviation because it's just looking at that one score. It's for whatever person made this score or scored this within this wide measure. So remember the formula. Take a moment right now. I want you to read the formula out loud to yourself and make sure you know what all of these different characters are within the formula. So pause here. 3, 2, 1. So what the formula says, if you're looking at the x minus mu, that's the deviation, right? How far you are away from the mean. At the bottom you have lowercase sigma, that is the standard deviation, and so if you want to put how far you are away from the mean with that one score over the standard deviation, divide that, and that's the ratio, that's the Z-score. If your standard deviation, like in the Wechsler intelligence test, if that is 15 in the score, and the standard deviation is 15, then 15 divided by 15 is 1. So you have a Z-score of 1, a standard deviation of 1, both are exactly the same. Yeah? So let's move on to next slide. Number 12. We have a Z-score of 1. What does this tell us? Well, if you look up in the table of areas under the normal curve in Appendix A, page 318, look up a z-score of 1. Do it right now. Okay, so the z-score is gives us a proportional value. The proportional value is 0.3413. If you multiply this proportion by 100, you get a percentage of results, a percentage of people who have scored between that z-score and the mean. Yeah? And so here with this z-score of 1, you have 34.13% of people who score between the mean and that z-score of 1. Yeah? Does this sound familiar to you guys? Yay! So that's the percentage that we see with the standard deviation, right? So 1 standard deviation to -1 standard deviation is going to be 68%, thereabouts. Divide that by 2, so it's just mean to 1 standard deviation is about 34% of people, yeah? And so here we have it. With the z-score, it has told us that. So let's practice this a little bit. It's moving on to slide number 13. I want you to look up right now the z-score of 0.25 and tell me what percentage of people are between the mean and 0.25. Look it up right now. 3, 2, 1. Now tell me what percentage of people are between -0.25 and positive 0.25. 3, 2, 1. So I want you to remember that in a normal curve, 1/2 of people are above the mean, 1/2 of people are below the mean. Yeah? So that means 50% of people are above and 50% of people are below. So given that as a fact, what percent of people score below a z-score of 0.25? Work this out for me right now. 3, 2, 1. Okay, I hope you worked it out. I'm not giving you the answers. Okay, let's practice some more. We have a z-score of 2.17. I want you to look this up and then tell me what percentage of people are between the mean and positive 2.17. Also look up what percentage of people are between -2.17 and positive 2.17. And now figure out what percentage of people are below a z-score of -2.17. Pause and think about this. 3, 2, 1. And what percentage of people score above a z-score of positive 2.17? 3, 2, 1. And what percentage of people score below a z-score of positive 2.17? Okay, going on to slide number 15, I do really want to encourage you all to practice this. Reading tables, just like we were practicing reading charts and different distributions and what we can learn for these. We need to understand the theory. We need to understand how to use these things in order to find out useful information about the data that we're collecting and the calculations that we're making, yeah? So if you haven't already, do your chapter homework by February 10th, Monday. And if you didn't do it during the first read-through of Chapter 4, I really do want you to work through each of those example problems that are in the chapter from page 83 on. They have the answers immediately, so it's really quick to just read through and not really think about it, but I want you to read through and work it out for yourself and make sure you understand how you are getting to each of these answers. Yeah. Make note of any questions or comments that you have and post them on La Lima Forum, or save them for class on Monday. We will have plenty of time to review and talk about all of these things before the quiz for Chapter 4. Yeah, so anything that you are not 100% clear on, make sure that you are ready to ask about it, have some comments, ask your peers on the forums or whatever. The quiz is going to focus mostly on comprehension of theory, and the ability to use the table, so make sure that you feel good about each of these things before we get to class on Monday. Slide 16. We are going to have the chapter quiz on Monday, February 10th. Like I said, plenty of time to review ahead of time, so don't worry if you're not feeling too clear just yet. We'll be able to talk about it some more to make sure that we're all clear and good on moving forward. After that, what comes next is our Chapter 1 through 4 test. This is going to be worth more of your grade than the quizzes, which aren't worth quite as much. We will review Chapters 1 through 4 on next Wednesday, February 12th. The entire class period is for review. We'll be able to ask questions and answer questions, but also I'll be able to go over the things that are going to be on the test for you, yeah? Monday, February 17th is a holiday. Don't show up. We will not have the test then. I will not be there, so there's no point in you being there either. The first test is going to be on Wednesday, February 19th. So be prepared. You'll have plenty of time to study and review. Anything that you're not clear on yet, just go back in the chapters. All of these first 4 chapters really kind of go together. Make sure for the test that we'll be going over the calculations again, but also theory and understanding what we're calculating. So it's going to really bring all of these things together. And also you'll see on slide number 17 and 18 that I lied because I did provide the answers for you, so you can check what you calculated earlier and see if it works out. So I will be away, but email me if you need me. I'll get back to you as soon as I can, and I'll have extra office hours next Friday. So if you need to see me then, just pop on by, and if you need me to come in for another time, that's also okay. Just let me know. And I hope you are all doing well. I will talk to you soon.